Hi guys, in this video I tell you about equilibrium. So let's start my video. Newton's first law of motion tells us that a body continues its state of rest or uniform motion in straight line if no resultant or net force act on it. For example, a book laying on a table or a picture hanging on a wall are at rest. The weight of the book action drawer it balanced by upward reaction of the table. Consider a log of wood and weight W supported by ropes and shown in figure 4.26. Here the weight W is balanced by the force Fs and F2 pulling the log upward. In case of objects moving with uniform velocity, the resultant force acting on them is zero. A car moving without uniform velocity on a levered road and an aeroplane flying in the air with uniform velocity are examples of bodies in equilibrium. Okay, understand? It's define equilibrium. A body is said to be in equilibrium if no net force action on it. A body is equilibrium thus remains at rest or move at uniform velocity. Condition of equilibriums. In the above example, we see that a body at rest or in uniform motion is in equilibrium if the resultant force acting on it is zero. For a body is in equilibrium, it must satisfy certain condition. There are two conditions of bodies to be in equilibrium. First condition of equilibrium. A body is said to satisfy my condition or equilibrium if the resultant of all the forces action on it is zero. Let n number of forces F11, what is this? F11, F23, F33 Fn are action on a body such that F1 plus F2 plus F3 plus Fn is equal to 0, delta F is equal to 0. The symbol of E is Greek letter called sigma, used for combination. What is this? Equation 4.9 is called the first condition of equilibrium. Okay. The first condition of equilibrium can also be stated in terms of x and y components of the force action on the body as F1x plus F2x plus F3x dot Fnx is equal to 0 and F1y plus F2y plus F3y dot Fny is equal to 0. Sigma Fx बराबर 0. Sigma Fy is equal to 0. A book laying on table or a pic hanging on a wall are at rest and thus satisfy condition on equilibrium.